Okay. Good morning to everyone. Thank you for attending this Icarus webinar. Let me introduce myself. I'm Cristina Terpessi from Igeos, and I'm the project coordinator of Icarus. I'd like to welcome you all on behalf of the whole consortium. And I think that we can start with the presentation, and I will give the floor to Corrado Orsini, one of the technical coordinators of the project. He will explain us some technical aspects and issues of the Icarus project.
Thank you, Cristina. And good morning to everyone. I'm Corrado Orsini from Telespazio, and I'm one of the technical manager of the Icarus projects, together with Alberto Mennella, that come from Top View. And so today we will talk about Icarus. At the end of the presentation, there will be a final question and answer section that will be moderated by Alberto. During the presentation, the chairman will mute your microphones. You can formulate your question on the chat at any time during the presentation. Also remember that the workshop will be recorded and will be available at our website. So visit our website. The agenda of the presentation will touch some points that are the Icarus key information, the Icarus purpose, the Icarus concept, and final, the Icarus high-level objectives. Then we have the question and answer section. So the names Icarus stands for Integrated Common Altitude Reference System for U-Space. It is a SESAR 2020 exploratory research. And Icarus project proposes an innovative and feasible solution to address the novel challenge of the common altitude reference inside very low level airspaces, with the definition of a new use space prototype service and its validation in a real operation environment. Some dates. The project start date was on 1st May 2020, and the project will end on 31 July 2022. So the Icarus, to address this challenge, we build up the Icarus consortium. It is made by partners of excellence with relevant and also complementary skills. There are Telespazio, Igeos, that are part of Leonardo Group and representing the large industries. There are Top View, Draw Radar, and Euro USG that represent the small medium enterprises, and Eurocontrol, that is a pan-European civil military organization dedicated to supporting European aviation. And last but not least, Polimi and Dicea, that is a department from University of La Sapienza, that representing the excellence of the academic world. As you can see from that picture, all the expertise required for the project implementation and necessary for the project success are covered. So let's move on the Icarus projects. The Icarus project responds to the challenge of finding a common altitude reference system for drones and manned aviation inside very low level airspace. And it proposes an innovative solution with a global navigation satellite system altimetry-based approach and the definition of a geometric to barometric transformation algorithm implemented by a dedicated U-Space services. So what are the questions from which Icarus starts? The first one is which technology should be used to measure the altitude at which an unmanned aircraft is flying, and what precision, accuracy, and integrated values. The second one is which procedural mitigation can be put in place to harmonize the common altitude reference problem for drones and other users of the same very low level airspace. And finally, which reference datum should be used to ensure that every user of a given airspace is flying in the same altitude 8 reference system. So Icarus aims to address this challenge by proposing a solution with the aim to define a universal flight altitude reference system based on a geometric approach and provide a use space functionality for strategic and tactical phases, giving real-time information of vertical distance to ground and conversion of different altitude reference system from barometric to geometric and vice versa. This solution will address harmonization and will ensure fundamental basis for vertical separation between manned and unmanned in very low level airspace. All of us know that today, without an egg measurements, we cannot separate traffic vertically. So the Icarus work will enable vertical separation, and with it, traffic organization schemes that enable high density operation. So Icarus can be conceived as a service to be distributed to the end users, manned and unmanned, as a microservices architecture on the pre-existing use space platform through an electronic flight bag or a web application. As said before, Icarus is a U3 use space service and is conceived with a microservice architecture where every single service has a specific function. The accurate cartography plus 3D ground obstacle will be used in collaboration with the DTM and DSM model to calculate the vertical distance to ground, but also to support the mission planning and the mission execution. The information service will alert manned pilots in case of crossing a GAMS. GAMS is a zones in which the aid is calculated through the WJS84 datum, and providing also the conversion required for general aviation users that use barometric altitude calculation. The vertical separation service will alert drones and their pilots on the actual vertical distance from ground and obstacle. And finally, the GNSS integrity and signal monitoring services will provide the GNSS status for the airpass operation. Using these GNSS services, it is possible to provide a common airpass altitude with a horizontal and vertical protection level of error. So all of us knows that the majority of drones make use of GNSS-based dual constellation receivers. This is the starting and focal point from which Icarus moves. The aid is calculated by Icarus using GNSS, in particular WJS84 ellipsoid datum, will be used as a standard reference system to provide a common zero altitude to all drones and general aviation aircraft on the geometric altitude mandatory zones. So in detail, Icarus provides submetric accuracy, vertical distance from terrain and ground obstacle, strategic and tactical deconfliction from ground obstacle, and the conversion from barometric to geometric altitude and vice versa for general aviation pilots. So here we are with the main objectives of the Icarus projects that are US common reference altitude at very low level, US ground obstacle awareness at very low level, and US manned flight reference. So let's start with the first one objectives, that is to define the technical requirements for high accuracy GNSS-based altitude measurements for drones, to enable a reliable and accurate common vertical datum for UAS common reference altitude. In particular, it has been analyzed the dual frequency multi-constellation GNSS receivers requirements for the definition of the main navigation parameters in the determination of the vertical component in different operational environments, taking into account the accuracy, the continuity, the availability, the integrity, the rural-urban environment, the controlled, uncontrolled airspace, and the X, Y, zeta U volumes of the U space. Then the second one, objectives, is related to the UAS ground obstacle awareness at very low level. In particular, the main task is to investigate the vertical accuracy and resolutions achievable by the actual DTM and DSM services for ground obstacle and terrain profile with respect to the geometric WJS84 datum. So it has been analyzed which DTM, DSM available model could be used during the strategic and tactical phases in order to have a situational awareness of what is surrounding drones that are flying and to separate them from terrain and ground obstacle. Moreover, an assessment in transformation errors introduced by the DTM and DSM service with respect to WGS84 datum has been analyzed and taken into account. A brief focus on the guns. We want to propose these very small zones in which it's mandatory to use the WJS84 datum as a reference for the altitude determination. The third one, objective of our works, is related to the UAS manned flight common reference. In particular, the main task is to design a tailored U-space service for DA translation from geometric measurements to a barometric one reference system and vice versa for UAS and manned aircraft. So we analyze the GNSS barometric translation model, defining the input and output parameters for the proposed services, the actors. Then we analyze the communication strategies for the altitude translation service delivery with respect to the classes of airspace and the actors of the airspace. And finally, we analyze an error budget estimation related to the errors introduced by the barometric and geometric datum translation. So I give the floor to Alberto Mennella, that is our technical manager, and will manage this question and answer section.
Thank you, Corrado, for your very good presentation. I believe it's not easy to communicate such a complex objectives in a very short time. So I would be happy to start with some points that you highlighted during your presentation. So in particular, what is happening now with drones is that drones are basically changing a little bit everything in traditional aviation. So what happens when a drones take off from a home point? So generally what happens now is that a drone taking off from its home point will set its own altitude at that point. So it will set zero altitude, 0 meters to the pilot. So what's going to happen if many pilots, many drones will share the same airspace volume? Of course, we need a common way to agree about a common altitude reference. So I would say that from this starting point, we should find eventually a point where drones word and aviation words, traditional aviation word, can eventually meet. So is there any particular question about the concept that Corrado explained? So if you have any question, you can disable your microphone and start talking. So I think we don't need a particular mechanism to moderate this session. So Are there any questions about Corrado's presentation? Okay, so if okay, another person from the consortium is joining, Pavel. So if there are no questions, maybe I can make one to you, Corrado. You have talked about the GNSS measurement, WGS84 datum, barometric measurement, or GNSS-based altimetry, which is a very interesting concept considering the dual frequency multi-constellation receivers that are available now on the market that promise a very, very accurate measurement. But why do we need a GNSS-based altimetry instead of a traditional barometric mechanism for measure the heights and the altitudes?
Thank you, Alberto, for the questions. Is a very good question and a focal point of the Icarus projects. Traditionally, in manned aviation, the acknowledged methods of determining the altitude of an aircraft was based on pressure altitude difference measurements. I'm thinking on QFA, QNH, and flight level, generally referred to a common datum defined by the ICAO standard atmosphere. So these methods of determining the heights are problematic for drones for many reasons. The first one is that the barometric pressure altitude is not very accurate. The atmospheric pressures over cities and is difficult to measure due to the high temperature gradients. Buildings generally radiate heat, in particular when there are large air conditioning units on top of them, whereas parks and lakes that could be nearby could be cool. So this could be considerably affect the measurements of the barometric altitude on an air pass system. And moreover, air pressure is not constant and changes over time, so the regional QNH does it well. If air pressure is used for the confliction between different airspace users, UAS may need to be able to change their QNH during the flight. And also the certified resolution of the barometric measurements in a manned airplane is 25 feet, which is very coarse to be used for the air pass. And finally, it could be very difficult to measure air pressure in an air pass because the rotors could be quite close to the pressure sensor. So this may cause constant changes in pressure. So measure the pressure for the air pass could be very difficult. And for this reason, we want to propose to all the users, also the manned one, an approach based on GNSS.
Yes, yeah, well, this is a very good point. Also considering that small drones may have some manufacturing problem for installing the barometric sensors very close to the rotors. So this is absolutely a good point. But considering also the service that we foresee in Icarus, so the translation service model, there's also this concept about measure and estimate dynamically such offset from a barometric measurement. So, for example, from a QNH reference to a fixed model, which is the one of the WGS84. So having such conversion, which is dynamic, as you just mentioned, may be something helpful also for other use space users that we do not expect at very low level, but in case such kind of users might need this information, this mechanism of translation might be a very good means for communicating such reference in a different domain. I seen hand raised. So please, yes, I give the floor to Mr. Zvok. I hope I pronounce it.
Fine, it's fine. You can call me Gunnar, which
Gunnar
might be easier. Thank you.
Thank you. Please.
Yeah, I'm from the German Aerospace Center. Hi. Thanks for having the opportunity to jump in here. Unfortunately, I missed a bit of your presentation, and I was not able yet to check your poster, so the question might be irrelevant to most of you. We work with drones as well, not that much in the project that I lead in this SJU wave, but we work with drones, with experimental drones, and what we usually stumble upon is to have either a reference altitude to the home position of the drone or above ground, and we sometimes mix it up, and the ground control station that allows multiple drones to be deployed sometimes has, or at least we have the difficulty to change that. So in most of our experimental drones, the relative to home altitude is still quite relevant. Is some relative to home altitude also in your concept, or is it, let's say, only the other ones that you mentioned?
Yes. Well, thank you for this question. I can answer myself, or if someone else from the consortium want to have a word. I've seen Pavel. Pavel, would you like to
yes,
spend?
absolutely.
Yeah. Thank you.
Let me put the camera on as we can see each other. Okay, so hello Gunnar, hello all. I think to answer this, to reply to this question, we need to divide the answer for two pieces. The first one is the reference terrain model. Sometimes we call reference terrain model as a DTM, data terrain model, or sometimes DSM, data surface model. And first of all, prior judging any reference height or altitude, we need to spread across the area the same DTM, DSM for all users. Okay, so what does it mean? It does exactly mean that the CIS Common Information Service or FIMS in the United States should keep DTM, DSM and broadcast the information to other users. So for instance, if I have a drone which take off from the takeoff position, we should know this takeoff position so we can calculate what is real height and what is real altitude of this drone above mean sea level. Okay, and also when the drones fly, okay, we know what was it, let's say, relative height to the takeoff position, and having actual and official DTM model, we can judge what is actual reference to the ground. So this is the answer to the question. I hope I was consistent enough.
You were. Thank you for that. I will probably try to see what our gap is in our concept that we use experimentally, and why that is not sufficient in some cases. And I will, of course, check your paper to get like some ideas. And if I may, I mean, I made a contact to Manuel yesterday or the day before already, so I could also come back to you if I may, if I have further questions or ideas from you, because you're so much more into that topic than I am personally. So thank you.
More than happy to go into the details.
Yes, thank you for your question, Gunnar, because it's one of the points that we are also addressing in our study. And as Corrado was mentioning during his presentation, the DTM, DSM models have been evaluated now, even considering what is already there on the market, what can be possibly taken into account, just to understand which is our benchmark now, and especially which is the requirement that we need. Because, of course, considering a WGS84 as a common datum, and we miss all the information which is above it. And since our VLL volume is roughly 120 meters, I mean, it's important to understand the requirement we need for separating drones, not only horizontally from each other, but also vertically from each other and from the ground obstacles. So this is a very important point in our study. We will be happy to interact with you eventually during the life cycle of the project. It would be really helpful to get feedback from you all.
Okay, great. If I don't want to steal time from any other participants who want to ask a question, so you may go ahead if anyone has it, or else I will continue talking. Because most of the times it's, let's say, sufficient to like place your ground control station at a designated or dedicated point, and then put the drone on the ground and calibrate it to 0 altitude, and then well, it's flying 20 meters above you. And if you're not in a very, very mountainous region, this is perfectly fine. But as soon as two come into play, and maybe two different ground control stations put at different places, it might, and as you said, separation is an issue, or it can be optimized to separation also in altitude. This can then become very relevant. So yeah, it is. Let's say your project goal is very important, I guess. Not if you fly one drone across a field, but yeah, in broader application, it's very important, and yeah, looking forward to that.
Yes, so basically, yes, I mean, if there are other questions, I mean, we can go ahead with other questions. Otherwise, we can continue on this interesting point. So, yeah. Okay, so yeah, I think we can continue to talk for some minutes on this specific talk with this specific point. As Pavel was mentioning and considering the question, the most important thing is to have considering regarding of the system we're going to use, altitude or heights. It is important to have the very same information, because what can happen that if two operators starting from different home points are planning their mission on a given database, on a given DTM, DSM models, what can happen is that these two models can have a big gap, so even of different meters, even 20 meters of gaps. So this we need that the very same information should be dispatched somehow to all users having subscribing this service. The reason why we chose at as first iteration the geometric datum, the WGS84, is especially because this model is present inside the every GNSS receivers. So it is, let's say, a good way to start our let's say, investigation. But of course, we might need the different reiteration on our first approach. Okay, we have another person that joined the webinar. So yes, there's another question from Ivan Montelieu. Hello.
Yeah. Hello.
Hello.
Ivan will be. Hello.
Ivan, sorry for my pronunciation.
Ivan will be just fine. Yes, thanks for the presentation. Really interesting presentation on the common altitude reference system. I just have a question. During the presentation, you mentioned building a database for obstacle, taking into account the altitude. So I understand that we have easy access to DTM, DSM. But how are you? Do you have any data source for getting the altitude of the obstacle object, or are you going to infer the altitude from some image processing analysis, or is this not part of your current project? Are you just working on a common altitude reference system? I'm just trying to understand.
Yes. Okay, I can answer the first part of your question, then I will leave the floor to
Sure.
Pavel or Christina. Okay, just to mention that our project coordinator is EGEOS, so they of course work with a lot of data sets of ground obstacles, because they deal with the geoinformation, handling different satellite constellations. So this information is something that will be handled in our project, but just for a very small and limited demonstration. So we are addressing the common altitude reference system, but of course the ground obstacles are part of the problem, because we need somehow to handle also with this information. Of course, there might be problems concerning let's say all the cycle of updating new ground obstacles, which might be somehow difficult to handle, considering the revisit time of satellite and how we can have available this information. So, but we still have in the consortium Drone Radar, which is working already on this subject with the Polish U-Space service provider. So they already have put in place some strategies to at least to identify a gap and try to understand how to fill this gap. So maybe Pavel can say something more about this point.
Yes, absolutely. So hello, Ivan. Again, when we started to analyze the surface versus obstacles or versus terrain, we come to the conclusion that we are still missing the definition of the obstacle. So what exactly obstacle is, okay? And when obstacle became surface, okay? So because the terrain is very simple, okay? So this is everything which relates to the ground, but surface relates to the building. So question is either scrapper is an obstacle, either this is the surface, okay? So this is the first definition we need to concentrate very much on. The second one is the legislative protection law for obstacles in certain area. So let me go into the details. Imagine that you have a public airport with the IFR procedures, okay? So this is by law protected that no one can put any obstacle in the vicinity. But the aviation definition of the obstacle is completely not adequate to the drone definition of the obstacle. Because if we put the mast on the building, okay, if this is just sole mast, okay, this is the obstacle. But if we put this mast very close to the very high building, then it's not an obstacle for us, okay? So we discovered a couple of the things, like the definition of the obstacle versus surface model. The second is the law protection of areas where we expect, for instance, high level of high level of the drone flights, and it's not about discovering the obstacle from the drone. This is all related to the, let's say, to the strategic deconfliction on the flight planning phase. So this is very, very broad spectrum of the questions. We would like to find the answers, and I hope we will find them during this project.
Maybe I can add just a few words on Pavel, and seeing that, as already said by Alberto, EGEOS works with geoinformation products. So one of the main topic of EGEOS work is to determine the standards of ground obstacle database and how to provide, as already said by Pavel, this database to the users, and how to update this database. So it's one of the focal point of our projects, and on which we are working on.
Yes, thank you, Corrado, for highlighting this point.
Did we answer the question? Maybe a question to Ivan now.
Yes, please.
Yes,
yes,
please.
thanks. Thank you. It was really helpful. Thanks.
Okay, thank you.
Okay. Are there any other curiosities, questions about our project, our presentation? I think we are a little bit, we were a little bit longer than what was expected by this session, but I think it was, there were quite interesting, a very interesting point that we discussed. So if there are no any other points, I think we can
just one short one
please,
before
please,
we leave.
Sure.
Gunnar again, thank you. Let me check if my camera works again. Okay. So do you see any impact on man traffic in not very low level airspace? So is there any, and that is more, I guess, a use-based question and not your project question, but is there any impact on your altitude reference system to the airspace higher than 500 feet? Or is the boundary, there is some kind of transition boundary, if I'm correct? So yeah, the question is there any impact on the man traffic in upper airspace?
Yes. Alberto, can I? Or?
Sure, Pavel, please.
Yeah, so again, a few things. Absolutely, yes, because thanks to the Icarus project, we think that we will talk again about the integration, not segregation of the traffic. I mean, unmanned and manned. So we believe that it will be the integration of the traffic possible thanks to the Icarus project. The next thing is we are just making the assessment of the something which we called transition layer for drones. Okay, so when you are flying out of the VLL higher than 120 meters, we would like to name this airspace, this layer, as a transition layer by similarity to the aviation layer. Okay, where from the bottom we have the transition altitude, and from the up we have transition level. Okay, and these 30 meters would help us to just reconfigure the barometric or let's say altitude systems to be adopted to the proper one, which is widely used in the manned aviation above the VLL as a QNH. But we also found the problem of the calibration of the barometric sensors versus, the speed and direction of the flight and so on and so on. So answering your question, yes, definitely. We would like to submit the transition layer for drones to manned world above the VLL. But again, we found a lot of problems that we need to address during the project.
Okay. Okay. So, are there any other questions? Or if not, we can close now our short webinar. Hope you enjoyed it. In any case, if you go on the poster session on the web application about Icarus poster, you can find additional details about our project. So you can go and visit our website if you like to get additional information. So thank you, everybody. Thank you all for participating, and we'll keep in touch for additional findings of the project. Thank you.
So,
thank you all.
Thank you, Alberto, Pavel, and all of the consortium that are here. And visit our site for other information, and let's keep in touch. So,
Okay,
bye-bye.
Thank you.
Thank you to everybody.
Bye-bye.
Thank you. Bye-bye.
Bye.
Bye.